class now is just a way of organizing, all those students in one particular a group. You get so if you bring it to context of programming now, say class is used to it's just like it used to define like in programming terms it's a blueprint of the class defined. That's just how I would say. But in child, I'll use the analogy of the class. That in class now, everybody in that class have different stages. But then the class still brings them other one particular people. So that we are all in one space. Thank you.
All right, thank you so much. Thank you so much. Right. So, just like Brian said, okay. Dr. Kelvo, Mikelvo. I hope I pronounced that right.
Yes. Hello.
Yes, go ahead.
Can you hear me?
Yes, I can hear you. Go ahead, please.
Okay, so basically, according to my understanding, so let's assume that each child is enrolled into a school and we have libraries where they can access reading materials, say storybooks, that is. So we can call the libraries the class and the storybook, that's the object. That's how I understand it.
Yeah, thank you so much. So I am sure now that you have a good understanding of what classes are. I like one word that Bright used, to organize. Right? So class is just a way to organize your code to emulate an object. And for a kid who is in primary 1, for example, or basic 1, or year 1, depending on how your country refers to that, they can see a class. Okay, they have year 1, year 2, year 3, year 4, year 5, right? Now, all the classes have things that are common to them, right? They are called classes, but then they are different in their own entity. But on a global, looking at it from the outside, they all behave the same way because they have a couple of students, they have a teacher, they have subjects, they write exams, they do all of these things the same way. But what they are doing and how they are doing it is entirely different. But under the hood, right, they are the same thing. Right? Hence why it's called a blueprint. But the basic idea or the main idea around classes is to organize your code. Instead of organizing them in functions, you are now organizing your code or organizing your functions, right, as code, right, so that you can actually emulate actions and behavior for your code to emulate actually was meant to actually emulate a human being, but then just general object because it could do more than just what humans can do. So yes, we understand that now. Now next, what is an instance? What is an instance? Anybody? You can just unmute and just speak.
Okay, in a layman understanding, I think an instance is like a copy of the original. Is a copy of the original.
Yeah, true. You're correct. Any other person?
In the context of the class analogy, I would say an instance is, let's say, a student in that class.
Thank you. Perfect. So, students in that class are the people that makes up the class. Immediately you assign students to the class per se, right? You've created a class. So the actual what I'm looking for is create, right? You've drawn a plan, the blueprint of the class. You have to now build from it. The moment you create, right, it becomes an instance of the class, right? So that's it. A class is just um, the moment of creation, right? And then there is a name for it, right? An instance is the moment of creation, while the instance of a class is called an object. It's what we refer to as an object. That's in the terminologies for programming. Instance is the creation, while the instance of that creation is called an object. Then we have encapsulation. What is encapsulation? Now, I don't want to be looking at this from um, programming aspect. You can just look at them from English perspective. No answer is wrong. Okay, so just say it the way it's coming to you. Yeah, right. Go ahead.
Yo, okay, let me use the example of capsule, this drug capsule. We know that the substance of the drug is usually, covered with those capsules. So I think encapsulation is just like, hiding some kind of details or something. That's just how I understand it.
Yes. David, what else is something? Hello, David.
No, not David, not David.
Okay. If you're not speaking, you can just mute. So, Bright, thank you for that. You are very, very much correct. Encapsulation is just hiding. And the word in itself was gotten from capsule, right? To actually hide some details away. Now, the details you're actually hiding is actually details about the class. And this is because of security. You don't want a function outside of a class or a process outside of a class to be able to access information within that class, right? Now, there is a concept in a security concept in web development or cybersecurity called cross-site request forgery, where they send a bot to visit the site, and then they just insert scripts into the URL and visit a site, hack details or perverse database and do all sorts to a website, right? But then to secure the website, you have to be on that page. That is what the cross-site request forgery, right? CSRF token. It's a token that makes sure that you visit that page, and then there are some things to check whether you are actually on that page. And then functions that you must click on to access things that are on that particular website. Right? I'm able to actually do anything on that particular website. David, David Michael, I'm getting echo from your end. You can just mute if you're not speaking. Please, thank you. Or the host can just mute him if he's unable to mute. All right, that's it. That is what encapsulation is. Just hiding data. Now we have abstraction, right? What is abstraction? What does it mean for something to be abstract? Yeah? What does it wanted me for something to be abstract. Okay, who has not spoken? Let me look. Okay, David Grace. Can you help us what you think abstraction is?
Well, I feel abstract is something that is not real, or I think that's my own term, something not real.
Okay, that's correct. That's correct. Justice. What do you think abstraction is? Justice Obasi. I think you can hear me. Ibrahim, you can go ahead.
Abstraction, my own understanding of abstraction is the ability of this object-oriented programming to play away unnecessary, just like play off pre-processed stuff. Taking away, if you take off anything that they are not necessary and bring the main thing in your function. I want my own view.
All right, thank you so much. So abstraction is just hiding details that you don't want out there, right? Just removing the unimportant details, right? For example, if I have something like this, right, here, let's say I have something like this, car dot start, right? Am I looking at this? What do you think a code like this will do? Probably it's going to start the car, right?
Ignition, yes, of the car.
Just to start the car. Now, by this, how the car was made, you don't need to know. What or how does it start the car? Is it by turning a key or powering up the battery or switching a module, or how is it going to start the car? You don't need to know, but all you know is that when I call this on this car is going to start, right? That is just the concept of abstraction, right? And this has to do with actually naming things, naming your variables, naming your methods, naming your classes, so that it's easier for the user to actually use it without actually having to worry about how it is created. Then we have inheritance, right, which is one of the main topics we want to discuss today, right? But we Africans, we are very, very peculiar and with inheritance. Our father's inheritance, our mother's inheritance, and our heritage and all of that. So what is inheritance? Right? What is inheritance?
Can you hear me?
Okay, I can hear you now.
Okay, so I would say inheritance is the possession of some traits or similarities from something, probably a parent to the children, something like that. Children from inheritance of possession of traits or characters from parents to the children. Yeah.
Or even properties, right? Or money.
Yeah,
especially money.
or properties, yes.
Especially money. I like the money one. Okay. The study teacher, go ahead.
Okay, to my little understanding, I think inheritance is an object having access to certain properties of another object.
True. Bright, you wanted to say something earlier?
I think the first speaker has said my mind.
Okay. From parent to child, right? Yeah. So that is just inheritance. Getting something from a higher order to a lower order, from a parent to a child, right? Or a senior to a junior. Me inheriting my brother's properties, or inheriting my father's nose, or my grandfather's DNA, right? So that is inheritance. And multiple inheritance, just me inheriting something from my father, and then my mother, and then my grandfather, and then my grandmother, and my brother as well, from multiple people, right? Then polymorphism. What is polymorphism? Does anyone know what polymorphism is? Anybody?
Polymorphism could be presenting, let's say, presenting a multi-phase. Let me put it this way: presenting an idea in multiple ways. For instance, you're creating an object. Let me say, for instance, you're creating a method, and your method, you could make it accept integer value, like align it to, you can use it to, I don't know how to put it, but making your object to be presented in multiple ways.
Yeah, you are correct. There is something else I'm looking for that you didn't mention. Anyone else want to try? We are discussing. So let's talk. All right, Grace, go ahead. Thank you. Grace, you can go ahead.
I believe polymorphism is like having two different colors, like they're from the same particular stuff, but they have different types, like different variables.
Yeah, you are also correct. So basically, polymorphism is just the ability for something to present itself in multiple ways, right? For a method to be able to do many things. For example, the plus sign, right? What is its function in Python? What is its function?
It's used for addition or concatenation.
Addition or concatenation, right?
Yeah.
Now, you can see that with that or, you are saying that it is dependent on a certain, how do I put this, circumstance, right? In a particular circumstance where you are working with numbers, right, it becomes an additional operator, right, to add values together. But when you're not working with data types, right, or other data types that are not number, right, but of the same data type, it is used to actually concatenate, especially for strings. Then for list, it is used to join instead of concatenate. Only one operator, right, doing multiple things in different scenarios, right? You'll get to see that. And lastly, we have
That's what it is. Like multiple inheritance. So let's say a particular class is inheriting other classes, other super classes. So let's say that child class now is inheriting maybe like 4 or 3 classes. So the method resolution order is a way of trying to make that class free. And in those 2 classes, those 2 super classes, there is the art method, the same method with the same name. So what method resolution order does is that it prioritizes the methods, all right, that art method based on the class that was based on the list, like. So let's
List
say
of inheritance.
yeah, so that's the first inheritance in that
That order.
yeah, that order. So just chooses the method based on the order. That's how I understand it.
Yeah, and you are correct. It's just like I always try as much as possible. I know I remember I said this last time. Try to separate programming from a language, right? So a method resolution order is simply, say for example, I have a bank. Let's say I'm using Bank of America. And in Bank of America, I have a savings account in that bank. I have a current account in that bank. I have a domiciliary account with that same bank. And I have money on all accounts. And I want to pay for something that is not in dollar, but in Naira. And I'm in America, right? What is the order of precedence to actually know where to actually deduct money from? Should I deduct money from my savings or from my current account of my domiciliary account that is domiciled in Naira? Right? What is the order? Right. So that's your way of choosing, right? So I'm saying, okay, I have these 3 accounts to give to you, and with these 3 accounts, whenever you want to get anything, right, always take from here first. Except it's not here, then take from here, then take from here. Okay, so that is just what that is about. So let's get to actually see actual code on what this is, what all of this is about. Sorry, I have to message someone. So that's settled. I want to open a folder here. New folder. Let's go this inheritance. No, definitely not here. Inheritance. So I have this open. Now I can put up my files. Okay. Main.py. Have this. Okay. Okay, so let's get cooking. So to create a class, right? Basically, when it comes to inheritance, inheriting is just getting from the parents, right? So we have something called a parent class.
Hello, Mr. Moses.
Yeah? Yes.
Please, sorry to interrupt. You can help us increase your font size a little bit.
Oh, yeah. Sorry, I forgot. Is it okay now?
Better. Thank you.
Which do you prefer, this dark theme or light theme?
I don't know. Personally, I prefer darker ones, but I don't know about others.
Dark theme is better.
Let's just try white and see what works best for you. So, which one looks better for you to actually easily see? This is white.
I think this is better for presentation.
Okay.
Better.
Okay, so let's work with this then. And I'm gonna switch back to my atom dark thing. All right, so we have a parent base class and a child or what is it called? A child subclass. Right, so we have this parent class and this, and now I will use this instead. So this will give properties to this, meaning this is inheriting from this, right? So let's say we have a class called parent. Who knows why this? Who knows why this P is in capital letter?
I think that's the form, the syntax.
Okay, it's not the syntax; it's just a standard that all
The
classes
standard.
should start with the capital letter and all functions should start with the small letter. So you can easily differentiate functions from classes because when you call classes, you will call them with parentheses like this, and when you call functions, you call them parentheses as well. So yeah, it's just a standard, not that it is recommended. It's not that it is the syntax. It's just a standard, a recommended standard. So here I have parent, class parent, and we have underscore init, and some of the things we have in addition to this, let's say parent's name, let's say none, or no name, and we have also we can also not specify, right? And then let's do age. Let me read this one so you can see. I hope you can see this.
Yeah. Yes.
Self dot name equals name. Self dot DNA equals DNA and self dot age equals age. So what I'm just doing is here is just giving them default values for when the parent is created. So let's say P1, right, which is parent 1, equals parent. And let's give this parent's name to be Matthew. That has double T, right? And then the DNA is just let's say 0101, and the age is let's say 35. Right? This is a parent. Now we have a child, right? And the child needs to also know his parents and all of that, and also get his DNA from the parents. So to inherit, I just have to call the parent class here. Just pass it there like that. And it's done. Okay. Now, I'll do something here. Let's just say pass. Right. And let's do child. Let's say child 1 equals child. Right. And now I want to do child 1 dot name and set it equal to let's say John. Right? John Doe. Let's just print here. Let's print C1.name and we do this and we print C1.name again. What do we get? So at first, I get no name. And secondly, I get John Doe. Right? So initially, the parent child had no name. And the parents of the child had no name. And later, we changed the name by assigning a value to it, which is updating the value, which is not supposed to be. Because from outside here, anybody can just change your father's name without you knowing. And you start bearing a new name that you've never even heard of. Now let's go. How do we fix this issue? What is the concept that fixes or shows us how to fix this issue from all of this? What is the concept from all of this concept?
Encapsulation.
Encapsulation, right? And how can I encapsulate this data here?
You make the name private by using double underscore.
Make it private by using double underscore. Right? And this fixes things for us. Right? Now, when I run this code again, we'll get attribute error. Child object has no attribute called name. But in fact, it has an attribute called name. Now, if I change this to, we change it to underscore underscore name and underscore underscore name and underscore underscore name, right? We get this. It still tells us that the object has no attribute name, right? And we'll try to call it, which is on line 18. It doesn't have this, but it has it, right? Now, we are not supposed to get this value like this. We are supposed to set a method if here, right? get name right here, and then we can just a bit empty like that. Sorry. So we want to just return self dot underscore name. Oh, sorry. Self here. Self dot underscore name. And we run our code again here. Now, we see that the error has changed from line 18 to now be, line 20. Yeah. Now, when we do this instead, get name, we get this. Right? We get no name, and then we get John Doe. Now, how did we get John Doe here? Or why did we get John Doe? Who can tell us how we get John Doe? How we got John Doe here?
I think because you define it. Huh?
We updated the value from outside here, right?
Yes.
Now, this is to tell you that even though you have used double underscore, right? Python still allows you to be able to do this outside. But now you have to set up a way whereby they shouldn't be able to do this from the outside. Meaning we have to set a method, right? And be able to do that, which is set name. Let's change name. Self, and then name. So int name will set self as name to now be equal to name. That way I can come here and do change name. Equal to John Doe this way, and our code works properly how it is meant to work. Now, there is something else happening here. Child doesn't have this, right? Because we try to change it from the child, not from the parent. The parent is not the one changing now. It is now the child trying to change. Right. Now, another good way is this. I can come to the child now and do this exact same thing here. I do this exact same thing here and run my code again. And I still get this is not working. Right? But then if I want to make use of this, there is something called super, right? I can call here. I can do, I think it's, sorry, let me look for that. Super dot equals name. Let's comment this out. And let's do this. Right. Super object has no. What is this again? Has no attribute child name. Self our child. So I'm not sure who's guessing here. That has no attribute super. Yes, it shouldn't have attribute super. So the super function is supposed to get access to the inherited class and then be able to actually alter whatever is there. Now I'm forgetting the syntax. I'm using higher level classes for a long time.
Mr. Moses.
Yes.
Yeah. So when I was studying on this thing yesterday, there was something I learned. I don't know if you can tell it.
I can't hear you.
Can you hear me well?
I can barely
Hello?
hear you.
Can you hear me
You're
now?
breaking up.
Can you hear me? Hello?
Okay, I think you're better now.
Hello?
You're breaking up.
Okay. So I was saying that there was something that I learned yesterday on this inheritance concept. You know, in this program now we have the child class having the same method name as the parent class. So I learned that if the child class has the same method as the parent class, the same name, what the Python program will do is to prioritize the class, is to use the child's method instead of the parent's method.
Yes, actually.
Yeah. So if that is so, the problem might not be coming from the parent class itself. I think since they're already the same thing, there's no need calling the parent class again, right?
The parent class, which is this, right?
That method. If I really get what you're trying to do.
Yes, there's no need calling this guy again. Let me just call this guy. See? On line 30. Oh, sorry. This is why I've been getting issues. Right? I'm supposed to use get name. Sorry. Get name. I return to a string. Not that. Sorry. The value I've been looking for is here. But then, yes. This is it. This is what we are trying to do. Yes, this is what we are trying to do. Now, see, look at this here now. Right? Look at this here. This is what I was trying to explain earlier. Let's remove this first. Now, you see, we're able to change the name, right? We're able to change the name here. And the name changed for this child. But for the parent, right, it is still no name. Why is it still no name? That is because this method we created here, right, it worked, right, but it couldn't affect this guy. And then if we had the same thing here, right? It gives us no name, right? Now, this is what you were saying. This method here, change belong to this child, is what was still used, which is why it didn't affect this. But if I put pass here, right, and just run the code again. Right, pass, I didn't commit. And just do this. I get the undo. Because now this method no longer exists. This method is what was used. Now, how do I get access to be able to change what is here from here? Is to now grant this child, right, power over what is here. Sorry. Now I can do super. I do this, and let's comment this out.
Hello, Mr. Moses, please ask some questions.
Yes.
Can I ask?
Yes, go ahead. Go ahead.
Okay, please, I wanted to understand what really is this self, what is it doing there, and that pass that you just typed in. So what are the functions? What are they doing?
This one here?
No, self.
Self?
Anywhere you type self, what is the function of that self? Because I think it's a function, and the pass that you just typed, what really is their function in this code? What are they doing?
Okay, the self keyword is the first keyword, right? In any when I initialized this parent class, right?
Yeah.
It had a self. It had a
Yes.
self. It created itself, right? Now,
Yeah.
I'm having issues with this guy because I didn't even create him. Okay. I'm coming. Let's get rid of this. Mhm. Okay, so let's do this alone. Now, this self, right? It's saying when I create this this guy here, right? When I call this, copy whatever is here from this blueprint, create this guy and store it here. This child, create this and from this blueprint, create and store here. This is the instance of the class. C1 is the instance of the child class. P1 is the instance of the parent class. Now, since I've created you, right? Since I've created you, now, since I've created you, copy all of this. Now, when I call self, please, when I'm calling these functions that are referring to self, which is himself, right? Which is the first variable here. This is self at child, right? And then this is self at parent, which is referring to this parent. Refer to yourself, each of you refer to yourself, and then call these methods based on yourself. Else, it will just be a function that is inside a class, not a method of that class. Am I confusing you all? Do you understand it now? I think I'm confusing you the more.
I am trying to understand. I think I will get it. I understand it.
Yes. Now, it doesn't have to be self, but the standard is it should be self.
Okay.
Okay. Now, this
Yeah.
self is referring to child. That is why it is called, this parameter is self at child. Right? This self is equal to the child class, belonging to this child class. This self, right, also belongs to the child class. You can see it. Okay? And then this get name, right? It just is a method. But if this, let's say this get name, let's remove this self from here, right? And look at this again. Still a method, but it's not going to work because it doesn't belong to anybody. This is just like a global function. Do you understand that? So I'm getting that back there now. Now, self is just referring back to whatever instance of that class you are calling that method on. So please tie you to yourself, or tie yourself to yourself, however you want to put it. Then when I write pass, I'm just saying, okay, I'm creating this guy. I know there's a code that's supposed to be here, but please don't worry, I don't want to write anything. I just look and pass. For example, if I do a function here, function by function,
Okay.
right? And leave it like this. You know there's going to be an error. You can see it's already aligned, underlining here. Expected indented block, right? But then if I put pass here, it works. Now there's no code here. There's nothing this function is doing.
Okay.
I call the function, it's not going to do anything. But I'm just saying, this is a keyword in Python saying, okay, I know I'm creating you, but I don't want to do anything with you yet. Just exist for me. I'll come back to you.
Okay, I get it now.
Yes, so that's that. So now let's run this code again and see what we get. Now we still get no name. I'm supposed to update this guy from here. Super any super parent. So let's run this again. Kind of has no parent underscore name. Yes, it has no parent underscore name. So it shouldn't be this. I'm forgetting, I don't write this type of classes again. I write meta classes, and I'm a bit rusty and don't know how this works again. So I'm
What
going
if
to
you try adding that super to the change name in child class? That changing method.
Yes, I don't super here. No, I don't think so. So there is this site. Programs. I think that's the name of the site. Yeah, that's the name of the site. So I'm looking for Python. I'm looking for not this. OP. So it has this. So it has what I'm looking for here. Okay. Nope. Yeah, I just recreated. Yes, so this is what I'm looking for. Okay. So I'm creating this guy. here, so call it here. But now I'm calling super dot info. And then passing link to it. I think that would go down. Yeah, passing to it. So yes, we have that. So this change name here, that is not going to work, right? So we have to create. Child has no underscore name. We have to create this and call this guy to not do the main work there. Type object super has no attribute change name. Super dot change name should have.
I think the super has a bracket.
Yes, it has. Oh. Yeah, so it now works. Change back to John Doe. Let me clear my terminal again. So that's cleared. So what we are trying to achieve here is to understand one major problem you face when you are writing your inheritance, right? Now there are times where you need to create the same thing for both, so you can actually call the format to actually update it. If you are working with Django for web or Flask, you face this issue. I think in your ALX you are going to do Flask at a point. For those of you who do backend with Python, you're going to face Flask. So the idea is how to access methods of the parent and be able to update them, especially for when dealing with private entities like private properties or even private methods. For example, if I have this method as this, right, this get name that is here, even if I put the underscore here and let's run it, it's going to give us an error that doesn't exist because that guy is a private class, so a private method, and this method cannot be accessed outside of this guy here. So maybe when we are doing change name, we should also return this function to get the name and just send it back. Let's just try it. Return underscore get name. So, okay. Okay, I don't think. Data equals this. Get name. Get name is not defined. Still works. Should still work. So we'll call change name. That should get that to work. So S3 will give us an error. And we get nothing again. So the idea is you can make things private, encapsulate things, or make things public. But the main thing with this is that this function can only be, this method can only be called within this class here. I think it's return self dot get name. Yeah, this is what we are looking for. And we can get rid of this get name just so we don't have issues and run. Child has no attributes, get name. Oh yeah, this too has to go. So we'll change name. It's going to also print change name. Let's print change name. We didn't print this. I'll return the value to it. So we get none because I asked it to return none. Where is it? I asked to return none. Get none. Okay. That's name. Self. Name. Yeah. Two positional arguments. One. Was given. That was one given. How do you expect two? Get name takes two. Takes one, but three were given. Yeah, three were given. Get name doesn't take anything. And it still returns none. Here. How do we shortchange this guy?
I think so.
Okay, we are first. Oh, sorry, we are not calling this guy. We are not calling this guy. Sorry, we are not calling this guy. This is the change thing we are calling. This is the change thing we are calling. Yeah. So we get an error again. And yes. So now do super like this. Super has no attributes. Child underscore. Get. Okay, we don't have get name here. Anyways, we are supposed to create a get name function inside here that's supposed to return this guy, but we don't have that as well. But I believe you already get the idea of encapsulation, which is hiding things and making it difficult for people to actually access outside. So you have to access it within. Now, for us to actually access this guy from here now, it's difficult, but to access it from here is still pretty easy, right? So I'm getting rid of this and returning this back to its origin. Now, single order score is also, I've forgotten what this is called. Double order score is private, and one is private, one is secured or locked.
Protected.
Yeah, protected and then private. So this is protected and the other one is private. Yeah. So you get the idea of encapsulation. You get the idea of what is it called again? Inheritance. And we've only done single inheritance here. So what I'm going to just do here is this. Let's get this back to its format. Let me just run this to make sure it's working fine. So it's working fine. I wanted to know if you guys had a task on inheritance that we can just work with to actually explain better. So I can comment this out and explain better. using a task that you have on ALX already?
This inheritance comes up next week on our calendar.
Sorry?
It comes up next week.
Okay. So from your calendar, what you are going to be given, what I think you'll be given on ALX is just the basic side, like return something, assess a value, inherit something from somewhere. Let's take example. What should we do to actually do multiple inheritance? Let's say we have a class, right, called engine. We have bus, and we have a class vehicle. We have a class car that inherits engine and also inherits vehicle. Us. Now let's come back here and define a method for start. Print starting vehicle, starting engine. Then vehicle, we have method start, right? That says print starting vehicle. And we have this, right? Let's have pass here. And let's say car equals car. And then we need to now do car dot start. Now, what do you think is going to print? Starting vehicle or starting engine?
Starting engine.
Not starting vehicle. Are you sure?
No, starting engine. I'm sure.
So let's see. So car dot start takes one positional argument, but takes 0, but 1 was given. Which one was? When was 1 given to it? 1 was given. Where was the given 1? On line 52, 1 was given to it. When? When and how?
I think that's self keyword. Maybe that's what's missing.
Okay. Car dev scope utilize out. So this I guess should be the 0, but 1 was given. On line 53. Siri is calling. Come on.
Where you have a dev start, you didn't put the self in the bracket.
Sorry?
For your dev start, no self.
Let's just do this. Okay, yeah, that was the issue. I needed to initialize each of them as objects, not just existing outside. So, what is printed is starting engine. Now, this brings us to our method resolution order. And this works with multiple inheritance. It takes the leftmost inheritance or leftmost class, right, and makes it and takes whatever method that was given to that. If I change this order here, right, I get engine is starting. Right, starting vehicle, because because vehicle is the first one, no longer engine. Because engine is now the second order. That is how Python actually sees them. Now, if I have something here, say start, and print starting car. Right. What should I get now?
Starting car.
Why starting car? Why starting car?
Because since the child class has the same method name as the subclasses.
As the base class.
So it's good. So Python is going to prioritize the method.
So the order is this. Python prioritizes child over inherited classes, 1, right? Now this is called method overloading, where you create a method to override a method that is in an inherited class, which is to change what it does, to make it do something else, right? To change that. Now, that said, then after the child, the next in hierarchy is the leftmost class that was inherited. Okay, so we have car, which is the leftmost, then we have the next, which is vehicle, and the next is engine. So if they are bearing the same method, this, if it exists here, this would be the one to be first called, or this, or this. Okay, that is just the order. So you understand this order now, and then polymorphism is just having this same guy. Start is doing different things, either starting the car or moving the car and doing this, or is doing this entirely, which you understand already. So these are the core things you need to know about classes. These first two are very important. These are questions that come out in your interviews, right? What is a class? And what is an instance of a class? Or what is an object? What is a class? What's the difference between an object and a class? Right? Those things. What is the difference between a data structure and a data type? A class is a data structure. The instance of a class is a data type. Okay? So that is that. Then encapsulation is just hiding data from outside of a class. And then we have abstraction, which is just making sure you name your things properly to actually follow a pattern. It's just naming. Right? Then we have inheritance, which is getting things from a parent class or a base class to a subclass. We have multiple inheritance, inheriting from multiple things, and then polymorphism, having different methods, doing different things, right? But then they are mostly inherited. There are times where they are not inherited, but they are on the same class, but the same method, but doing different things as well. Then the method resolution order. Right? This is how you know what is coming. So method resolution order is from left to right. So car before vehicle, before engine. If it's just inheriting just engine, it will be car before engine. If the method exists in both of them. Do you have questions for me that I can answer? If you have questions, you can just ask.
Okay. Sorry, my question is this. Like for instance, if a child inherits the initialization from a parent, if a child inherits the init setup from a parent, can we add other attributes to the child class? And if
Yes.
so, can you give us an example, please?
Yes. So this is a child car, right? And this car can have attributes like maker, which is the manufacturer. You can have model. You can have year, right? While the engine can have type of engine, right? And then you can also have the model, if it's a V8 or whatever. Now, at the point of me calling this guy here, I'll need to do something else, which is create that engine, right? I think I'll do that again. I've forgotten how it's done. That's cool. So super dot init here. Let's make this self dot type equals type, then self dot model equals model. And down here we have the type of engine and the model here. So the type of engine can be let's say Google engine, and the model is V8 engine. Have this, and we inherit the car. Now we can simply just do let's bring car dot model. Take some position and 7, 6. You need takes 1, but 3 were given. How was 3 given to this guy? Okay. All right, so we have Okay. We need to create something and pass down to this guy here. Come in. Let's pass. And let's see this. A has no attribute model was never created. Car is from car, and then it's from engine. But engine was never created, so it doesn't exist. And now we need to create engine here. How do we create engine here? I need to come back to the basics. I'm used to the Django writing meta classes. And I don't need to actually be specifying what I need. I can just pass them as meta and it does all the work for me. Now this is one thing abstraction does for you, because all of these classes are actually meta classes. I can just pass them as meta and then it does the work of initializing all of them for me. And now I'm losing my basics. But then the idea is this, right? Each of these can have their own variety of values. Like this has a model and all of this. And yeah, this can have as much as it needs to have as well. And then just have to initialize all of them here in your init as well and have access to them. But then what you need to focus more on is your what is it called? Resolution order, right? Now, data that are private to this, make them private. The ones that are protected, make them protected. The ones that are public, make them public. But then the inherited values are still inherited safely from here, right? From the engine. They are still inherited safely from the engine. But then I don't know why I'm unable to actually access them from here. That's something I will find a way to fix later. So car doesn't take any variable, right? But then engine needs to take at least 2 variables. We pass them here. No, I don't think we pass them there. We need to find a way to pass this data back to this. Super underscore init. And we can pass this here. Let's see. And run. Type error init takes one token argument, but none were given. So self. Init takes 1, but 3 were given. How are 3 given? Online system 3. 3 were given. Self, Google, and V8. Yes. But it takes 1, and 3 were given. Two arguments were given.
I think it's the vehicle class is the first super class there. So if you check the vehicle method, it only takes 1 argument. The init method takes only 1 argument. Maybe that's where it's coming from.
And then 1 is given already here. super dot self dot model. So car has self dot model. It has access to self dot model. And I can catch that here. Bring that successfully. Okay. Let's say car model equals it. Just run this again. And we get the it. So it wasn't given before. This was the issue. It wasn't given. And from here, it was created but never given. Yes. It was created but never given. That value. And until the value is given, it didn't exist. That was our issue. Fixed. Just something basic as this is what I'm talking my head about. Anyways, back to what we're saying. I can keep giving this guy as much attributes I need to give, and then as much methods I need to give. It doesn't matter what I'm saying or doing to it here. Let's say the car has a make, right? And then a year, and then mileage. So I can come here, the make is Ford, the model is Hilux, and then the year is 2023, and then the mileage is, let's put that there, and if we get this, now I can do this sorry, I didn't save that. I just passed. Self dot make equals make. Self dot year equals year. Please save it. Self dot maybe equals image. And we get the correct answer now. Attribute MI. Which MI? Okay. So we get the mileage here. What is all we need? So, like you asked, we can have more attributes here. We can have more here. We can have more here as well, right? It doesn't matter what is there, but then make sure that the attributes and what you are doing here relates to what you are doing. Now, the major work of a programmer, right, is not to sit and start writing code. That is why when trainings are being conducted, I always advise that you teach user flow, right? Or what is it called? Program flow, or there's something is called where you use shapes to actually do the flow chart. Yes, flow chart, how to write or draw flow chart of your program. Design that. If you know how to design that, or write pseudocode to actually know what you want to do before you come to start writing code, it becomes very easier because you already have all your mistakes there. It doesn't flow well in your flow chart. It's not going to flow in your program, and that is easier to actually understand because you're just talking English language there or in your pseudocode. Anyone you prefer to use pseudocode or flowchart. Use any of them to actually write or structure what you want to do before you come to start writing your code. If you're writing from the top to the head, you start having issues like I'm having. So I have my book that I always jot down or write or draw before I actually open up the piece to actually start writing anything. So I think that answers your question. Study teacher.
Yes, thank you.
Yeah. Somebody else wanted to ask a question. I think it was right. I saw the hand raise the other time.
No, not me.
Okay. Who else wanted to ask the question? Okay, so in the absence of no question, I think that's enough to call it a night. So your take home today should be that before you write any code or set to write any code, please try to write your flowchart or pseudocode first. At the LX, were you taught how to write flowcharts or pseudocode?
Yes.
Very good.
We have both of them.
Very good. That's the first thing that any programmer is supposed to actually learn, and your first go-to for doing. That's the very first. You have a book that you write all your stuff on, more like a jotter or something. Right before you actually go to your computer to code. You don't code from the top of your head. You meet unpredicted bugs. Anyways, I think that's everything. I'm exhausted from work. Just jump from work to this class.
Oh. Wow.
Anyways, thank you.
Thank you very much, Mr. Moses.
Thank you very, very much, Mr. Moses.
Thank you very much, Mr. Moses. Good night.
I don't know if anybody has any other question.
If you have any question, right, you can always just send them to my DM. That's my. Why did Elon Musk change this icon to this? Just change Twitter loader for nothing. So this is my account _local. I'll just place the link. Just my DM is always open. You can ask whatever questions you want to ask on. Let me just post it in the chat. All right, so that's it. Whenever you have it, just save it in put the link on your notes or wherever. If you have questions, you can just shoot up my DM.
Wow. Thank you very much, Mr. Moses.
All right.
With this now, I think we can start on.
Yeah, you don't have a lot of questions.
Please, if you can as well help us with the codes.
Yes, I will. Let me just add it here. Let me send a link to you guys to keep here. Right. Share access to the folder. Also, let me share the folder with you here. What did I call the folder? Inheritance. Yeah. you can download using that link. Share it with you. You can share it with your that groups as well. So yeah, that's the just say that.
Bearing with us, I know Mr. David was not around. I think he had some issues, so that's why he couldn't come. On behalf of him, I want to say thank you very much. To impact knowledge is not actually easy, but at least you came down to our level and did the needful. I want to say thank you very much. We appreciate it. Then for those who stick with us, who are still around, I want to say very big thank you to you. You all are making this group come alive, and your efforts are not looked down on. I want to thank you. I appreciate you. I think
For those of you who stayed up till this time, you can send a message on Twitter if you really want to learn Python. I have a great course I just purchased on Udemy that I can give you my login access. You can log in and just use. Just again here, if I know not everybody wants to learn Python, but if you really want to learn Python, the guy is the greatest Python teacher I know in the world. That's President Jao. Really popular professor.
okay. Okay. Thank you very much.
So I'll just show you the login details to the course and you have access to it. Yeah, very open. We're writing programs for since compiler language, since assembly language. That was his first language, assembly language. He has great. You can check his blog out. I come here to read a lot. He writes really good articles on helping programmers and solving problems. Right. What to do after completing the course, computer hardwares, gate circuits and switches, Boolean operators, series, history of the computer, blah blah. Like he has, compared to anybody else in the world, he's the greatest to me.
Okay. Wow. Okay.
I wanted to start a blog like he has, but I was seeing his content. I just stopped because who could do it better? Come on. Yeah. So I just refer people to him instead of going to write articles like this.
Okay.
Yeah, so you can just DM on Twitter.
Thank you very much, sir.
Alright.
Thank you very much, Mr. Moses.
Thank you very much.
This way we can
Thank you, Jason.
wow, thank you very much.
Thank you, everyone.
Thank you.
Thank you.
Thank you very much, everybody.
Thank you all.
Thank you.
Welcome from us.
Good night.
God bless your night.